Welcome back to the classroom. Today's topic is what is 8051 microcontroller and what are the application of 8051 microcontroller. The 8051 microcontroller is a type of microcontroller that has an 8-bit data bus and a 16-bit address bus. It can access a code memory space of 64 kilobytes and a data memory space of an additional 64 kilobytes using the 16-bit address bus. The microcontroller has a total of 40 pins and includes 128 bytes of internal RAM. It also contains several special function register SFR such as the accumulator, the B register and various control registers. The ALU of the microcontroller can perform 8-bit operations at a time. Additionally, it is equipped with two 16-bit counters timers, 3 internal interrupts, 2 external interrupts and 4 8-bit input-output ports. The 8051 microcontroller is a popular embedded system that has a strong interrupt system. Interrupts are crucial for external communication and real-time applications. They allow the microcontroller to respond to external events and requests, improving its multitasking capabilities. An interrupt is an event or command that interrupts the normal processing of the microcontroller and notifies it that a device needs its service. When a device requires service, it sends an interrupt signal to the microcontroller. Upon receiving the signal, the microcontroller pauses its current program and attends to the external device's request. This video is sponsored by Genreviews. The program associated with the interrupts is called an interrupt service routine (ISR) or interrupt handler. Next one is interrupt of microcontroller 8051. The 8051 has two main types of interrupts, hardware interrupts and software interrupts. Hardware interrupts are triggered by external signals such as peripheral events or external devices. The microcontroller can be configured to respond to specific events, enabling efficient event-driven programming. On the other hand, software interrupts are initiated by specific instruction in the program code. They allow the programmer to force the microcontroller to interrupt its normal execution and execute a predefined routine. Next one is interrupt structure of 8051 microcontroller. The 8051 microcontroller has an interrupt vector for each interrupt source, which contains the address of the corresponding interrupt service routine ISR. When an interrupt occurs, the microcontroller saves its current state, retrieves the ISR address from the interrupt vector, and executes the ISR. After the ISR completes its operation, the microcontroller resumes the interrupted task. There are two SFRs, means special function register, in 1851 or 8051 microcontrollers that control the operation of interrupts. The IE means interrupt enable. Register is responsible for enabling or disabling the interruption function, while the IP register is responsible for assigning priority levels. The priority list consists of 3 levels. Reset, which stops everything and restarts the microcontroller when a reset request is received. Interrupt priority 1 can be disabled using the reset function, and interrupt priority 0 can be disabled using both reset and interrupt. Additionally, some of the registers used in this microcontroller are number 1 interrupt enable register, number 2 interrupt priority register, and number 3 is timer control register. Now first one, interrupt enabled register. The IE, it means interrupt enabled register. The IE register in the 8051 microcontroller is responsible for enabling or disabling interrupts. It has various bits including EA, which globally enables or disables all interrupts. When EA is set, all interrupts are enabled, and when cleared, all interrupts are disabled. Additionally, the ES bit controls the interrupt for serial communication, allowing it to be enabled or disabled. Number 2, interrupt priority register. It is impossible to predict when an interrupt request may occur. If multiple interrupts are enabled, it is possible for another interrupt request to occur while the first one is still ongoing. A priority list is used by the microcontroller to determine whether to respond to a new interrupt request or continue with current operations. The microcontroller restarts when all activity stops in response to a reset request. Only the reset function can disable interrupt priority 1. Both reset and interrupt priority 1 can disable interrupt priority 0. The IP register indicates which interrupt source is more important than others. The program start usually sets the interrupt priority. If a highly priority interrupt occurs while another interrupt is in progress, the current interrupt will be fast and the higher priority interrupt will be given performance. If two interrupts with different priorities occur simultaneously, the higher priority interrupt will be handled first. If two interrupts with the same priority occur one after other, the second interrupt will have to wait until the first one is completed. Number 3. Timer controller register. External interrupts are the interruptions that the microcontroller connects with external devices. These interrupts are received through the INTX pins of the controller. They can be triggered by either edges or levels. When the INTX pin is level triggered, the interrupt is enabled for a low signal, and when it is edge triggered, the interrupt is enabled for a high to low transition. The type of triggering, whether edge or level, is determined by the T-con register. For a level trigger interrupt, the INTX pin must remain low until the interrupt starts and then go back to high before the interrupt ends. If the low signal at the INTX pin changes to high before the interrupt service routine ISR begins, no interrupt will be generated. Furthermore, if the INTX pin remains low even after the ISR has finished, the interrupts will be generated again. Therefore, the level trigger interrupt at the INTX pin must be exactly 4 machine cycles long, neither longer nor shorter. Next one is the study of application of 8051 microcontrollers. Interrupts play a crucial role in real-time systems by allowing quick responses to external events. The 8051 microcontroller is a suitable choice for application that requires precise timing because it can swiftly switch between tasks using interrupts. In communication applications, interrupts are used to control incoming data, ensuring timely transmission and efficient handling of received information. In embedded systems, 8051 interrupts are frequently used for tasks such as interfacing with sensors, where the microcontroller needs to respond rapidly to changes in the environment. Interrupts are also helpful in situations where data needs to be sampled and processed from sensors or external devices in a timely manner. In security systems, interrupts enable immediate reactions to sensor triggers or alarm situations, ensuring prompt alerts and appropriate responses. Next is advantages of 8051 microcontrollers. Interrupts can be utilized to quickly address issues, leading to better error detection and handling, ultimately enhancing the system's stability and dependability. The 8051 microcontroller's ability to operate in a low power mode and only wake up when an interrupt occurs aids in improving the energy efficiency of battery powered applications. By breaking down complex processes into smaller subroutines, interrupts enhance the code's readability and organization. The interrupt system allows the microcontroller to be interrupted by specific events, reducing CPU overhead and improved overall system performance. This eliminates the need for constant input polling. Certain variations of the 8051 microcontroller offer interrupt priority levels, allowing important tasks to take precedence over less important ones. This enhances system responsiveness and control. Next is the disadvantages of 8051 microcontrollers. The 8051 microcontroller has a limitation on the number of interrupt sources it can support due to its two external interrupt pins, INT0 and INT1. The interrupt priority of the 8051 cannot be changed dynamically and is fixed, which can make it difficult to handle multiple interrupt sources with different priorities. The microcontroller's response time to an interrupt can vary, which may impact a real-time application that require consistent and reliable response times. It is important to carefully program the microcontroller to avoid unexpected behavior when handling interrupts, especially when dealing with nested interruptions or critical sections. Unlike some modern microcontrollers, the 8051 does not have vectored interrupts, so it is necessary to manually check interrupt flags to determine the source of the interrupt. This is the brief study of 8051 microcontroller. Thank you for watching.